Hi everyone, today I'm presenting the UVBs and the IR spectroscopy. I will start talk about the UVBs first. Ultraviolet visible spectroscopy is an absorption spectroscopy. It absorbs a photon and then excites an electron from its ground state to an excited state, provides a limited amount of qualitative information. The instrument for UV spectroscopy has four basic parts: a light source that will generate a broad band of electromagnetic radiation, a dispersion device selects a particular wavelength of light from a continuous source, a holder for the sample, and a detector to measure the intensity of radiation by converting a light signal into an electrical signal. It also connects to a computer to record data. UV spectroscopy is used to analyze the solution of various organic and inorganic compounds. We will prepare several standard solutions of the sample at different concentration, and concentration of these solutions typically only has few micromolar. The sample holder is made of plastic, usually called cuvette, as shown in the picture. The most common capacity is 3.5 ml for a standard 10 mm cell. The cell should be handled carefully to avoid touching the optical surface. Before putting in the instrument, observe the beam path direction of the spectrophotometer. Insert cell make sure that the optical surfaces are facing the beam path. The ideal solvent for the preparation of sample solution should dissolve all types of compounds, should be non-flammable and non-toxic. Also should be completely transparent at all wavelengths. For example, distilled water, hexane, or ethanol. The original data we get from the computer is absorbance at each wavelength of every single concentration. Then need to calculate the correlation coefficient in order to define the most suitable wavelengths to perform a calibration curve, which is absorbance versus concentration of standard solutions, and then apply the Beer-Lambert's law. The concentration of unknown sample can be calculated. To construct a calibration curve, the spectra of a set at least 5 standard analytic solutions should be measured. Ideally, all measured standard values would lie on a straight line, but in practice, the values always exhibit some deviation. A statistical method must be applied to find the best fit of the calibration curve to the data. The statistical method most often used is linear regression. The closer is to 1, the more precision curve will be. Okay, then let's move on to the IR. Fourier transform infrared spectroscopy is one of the most powerful analytic techniques, which provide the possibility of chemical identification. This technique is based upon the simple fact that a chemical substance displays marked selective absorption in the infrared region. In order to detect the IR signal, radiation in the infrared region of electromagnetic spectrum corresponds to the energy required to excite vibration in chemical bonds. Polar bonds are associated with strong IR absorption, while symmetric bonds may not absorb at all. The basic instrumentation setup for an infrared spectrometer consists of an energy source, an interferometer, a sample cell, a detector, an amplifier, and a recorder. The energy source will generate radiation, which passes the sample through the interferometer and reaches the detector. Then the signal is amplified and converted to digital signal by amplifier. Finally, the signal is decoded by applying a mathematical technique known as Fourier transformation, which converts a function of time into a function of frequency. As infrared spectroscopy has been used for the characterization of solid, liquid, and gas samples, but these samples have to be treated differently. For the solid sample, either place a few micrograms of solid directly on the IR plate and add one drop of solvent, or dissolve the solid in a small test tube, then transfer it into the IR plate. The used solvents are non-aqueous solvents, such as tetrachloromethane and the chloroform. To prepare a liquid sample, only one drop of the liquid is enough. Put it on salt plate, and then place a second plate on the top of the first plate. And in order to introduce a gas sample, first connect one of the taps to a vacuum pump and open it to evacuate the cell. Importantly, gas samples are enclosed in a gas cell with windows, which seal the gas cell and allow the infrared beam to pass into the cell. The IR spectroscopy obtains the intensity based on the wave number. Hence, the most widely used application of IR is to identify the functional group in a compound, because different functional groups will exhibit certain wave number in the spectrum. Moreover, it's also helpful in determining molecular structure of unknown substance from our examination of the position of absorption band in the spectrum. Now I will talk about advantages and disadvantages for these two spectroscopies. UVVs can give extremely accurate results, as well as cheap and easy to operate. However, if there is impurity in the sample, it will reflect light and causes a decrease in absorbance. It will reflect light and cause a decrease in absorbance and reduce the linearity range of UVV. Compare it to HPLC, which is able to separate those compounds to get a more accurate result. Furthermore, IR spectroscopy is fast and inexpensive. On the other hand, the signal may overlap on the spectrum and will be difficult to differentiate. Based on this, the 1H NMR can be used to determine a functional group as well as its position in the molecule. Finally, I will talk about the quality assurance and the quality control. The internal standard could be used to adjust the instrument drift. Also use a fill blank to check whether the sample is contaminated or not. Multiple replicates of sample can be used by repeating the measurement of the sample in order to check the precision of the method. This is the end of my presentation. Thank you for listening.